So for this section, we're going to maximize and minimize, find the maximum and find the minimum of different objects. These are word problems, so they'll give you information about the functions. This should sound familiar to you from pre-calculus. We did spend a significant amount of time working at these kinds of problems. We are going to obviously handle it in a different way this year. So we have our problem, and it says find the points on the graph of, and our function is 2 minus x squared closest to the point 0, 1. So I've graphed our function, and then the point 0, 1 is right there. So we're trying to find the point or points that are closest to that. So I'm going to say, well, let's do a representative xy. So we're really trying to find the ones that are closest. Closest should indicate to you that we're talking about a distance. So if I plug these into my distance formula, remember you can also make a right triangle with these. My x's, I'm going from 0 to x, and my y's, I'm going from y to 1. Now if you have those switch around, 0 minus x and 1 minus y, you'll get the same after we square them. So I'll get x squared plus, and I don't want everything in terms of x and y. I do want everything in terms of just x. So I know that f of x is the same as our y. So what I'm going to do is substitute that into our equation. That should look familiar. I did that last year also in pre-calculus. So if I do some simplifying here, I'd have 1 minus x squared squared. Do the FOILing. And collect like terms. Okay, and then last year we talked about, and we can talk about it shortly here, is if I'm trying to find the maximum or the minimum, in this case it does say closest, so it should be a minimum, value of a distance. So let's make just a little table here. Let's say 0, 1, 2, 3, and we get 1, 7, 3, 2. So if we're looking at these values, the 1 is the smallest number. Let's say we made another extension of the table and we did square roots. Square root of 1, square root of 7, square root of 3, square root of 2. Now if we were to evaluate those, we'd also know that 1 would still be the smallest value. So whatever makes the function that's underneath, or the value that's underneath, smallest or largest, this first for largest, will also make the resulting square root smallest. So I'm really looking at this function. Now in pre-calculus, the way that you did these problems is you would always find the vertex, negative b over 2a, and substitute the values in and find the maximum or minimum. Now we can do a little bit more sophisticated work, which also means that we can evaluate more problems with this one. And we know that the maximum or minimum always occurs when the derivative of the function is either 0 or undefined. Now our polynomials, we know our polynomials, there's never a point that it's undefined. It is a continuous function. So we know that we're looking for only our zeros here. So if we factor, we'll have 2x we can pull out, which leaves us with zeros of 0, and then positive, negative, square root of 1/2, which is square root of 2 over 2. Now you could make a sign chart with this, or we could also just find what the different distances would be and identify which one is the smallest. So if I'm at the point 0, 1, or 0. So where is my, we'll make it over here. Our function was 2 minus x squared. And we have our distance is square root of x to the 4th minus x squared plus 1. Let's just find which one is the closest before we actually find the point. So if the x is 0, the distance would be 1. If x was square root of 2 over 2, the distance would end up being square root of 3 over 2. And if it was negative, the distance would still be the same. So the smallest two distances will be at these 2 points. So there happens to be 2 points. So make sure we do complete the answer. The question was, which two are the closest points? So when f is square root of 2 over 2, my y value would be 3/2. And at negative square root of 2 over 2, I also get 3/2. So if we go back to our curve here, the 2 points that we're talking about, actually I drew it almost, the 2 points, I'd have square root of 2 over 2, 3/2. And the other point is square root of 2 over 2, or negative square root of 2 over 2, 3/2. So those are the two ordered pairs that are closest. Do make sure that you answer the question. Sometimes they will ask you, what is this a minimum distance, which in this case would be square root of 3 over 2, or ask you about where does it happen, which in this case is what it did. Let's take a look at another problem. We do have a word problem here. So we're going to make an open box from a rectangular piece of cardboard. And we know it's 12 inches long and 8 inches wide. And we're going to cut off equal squares. So I'm going to make these x. So I know all of these values are x. And then you're taking off of those x's and folding up your box. So make something like that. So let's talk about what's left over. So if I have 12 all the way across this bottom and I'm taking away x and x, this part would actually be 12 minus 2x. So this side is 12 minus 2x. And this side, we're doing the same thing, so that would be 8 minus 2x. And then we cut off x's on every side, so our height, let's put it here, is x. So if we were writing our volume, because it does ask us what to maximize, volume of a box, remember you just multiply all of the sides. So this is our volume, but I need to step back a moment here and talk about what the values of the sides can be. Our sides have to be measuring something. So this side, I'm going to erase this 12 here. This side, the 12 minus 2x, all the x's have to be greater than, or I'm sorry, less than 6. Because if it was anything greater than that, I'd have sides of negative, so I'd have negative values. You could do equal to 6. Now that one's going to be a little confusing because the side would be nothing long, so it'd be like there'd be nothing left. But you could have no volume is perfectly reasonable. But there's nothing there. And then this side, all the x's would have to be less than or equal to 4. So really looking at those, in addition to just our x's alone, x has to be greater than or equal to 0. So let's talk about all of those in combination with one another. So really we're saying our domain, we could cut off nothing, Or we could cut off at most 4. The 4 is the most restrictive with this one. If you did 6, this side here would end up being a negative side, which you can't have negative side. So we need to keep in mind our domain, so we check our endpoints. You would then distribute those values to find an expression for the volume. I would suggest you can multiply it all out, or you could use the product rule. I would suggest multiplying the x through to one of the two, so we can use the product rule. So remember, maximum minimums happen when the derivative is 0 or undefined. So I have our first term and our second. So when we use that product rule, so after using product rule, I will get this, and then I can FOIL these first two. And distribute the negative 2. And then collect like terms. So I have an expression for the derivative. And I can find where that is, well, it's again, it's a polynomial, so it's not undefined. So probably to be most efficient, if I factor out a 4, of that. So I'm really looking for, well, when is this quadratic equal to 0? So I can use my quadratic formula. And I can reduce these. So I get those, and I want to find, just as approximations, if I add, I'll get that. And if I subtract, I get approximately 1.569. So let's go back. We've already talked that the domain has to be between 0 and 4, so we can eliminate that value. So we're under checking the volume for whichever one is the largest volume. We should check the endpoints of 0 and 4 in addition to our x that we found the maximum at. So we plug that into our volume formula, which, let me rewrite it here. I plug in a 0, I will get a 0. If I substitute in the 4, I will get a 0, which makes sense. Those would be the minimum volumes of 0, which we aren't looking for. And if I plug in the 10 minus 2 root 7 divided by 3, I get approximately 70 or 67.604. Let me go back and check what my dimensions should be. So the original one was 12 inches by 8 inches, so those would be inches cubed. It would be the maximum area. Now, you could extend this problem, or they could have asked a different question. They could ask what are the lengths of the sides, in which you would find the length of each side using that given x value.